Hi, I'm John Johnson, Editor-in-Chief of Secrets of Home Theater and High Fidelity. In this video, I will show you how transistors work and how they affect the sound quality in high-fidelity audio. In 1950, John Bardeen, Walter Brattain, and William Shockley received a patent for the transistor. They invented this device in 1947 at AT&T Bell Labs. Here is a photo of the first transistor, the one that Shockley et al. Built. You can see a paperclip at the top indicating the size of the transistor, maybe a couple of inches in height. High-powered transistors are still pretty big, but these days millions of transistors can fit on a computer processing chip, although they are limited to very low voltages. Not all of the glory goes here, though. In 1930, Austro-Hungarian-American physicist Julius Edgar Lilienfeld received a patent for what is actually a field effect transistor, or FET. In any case, the transistor went on to change the world and is the basis for computer technology. They started out with tubes but were replaced by transistors because of their advantages. The same holds true for audio, but we are getting ahead of ourselves. Transistors act as switches which allow a large bias voltage to be passed when a small signal voltage is applied. They also allow higher currents to flow from the output when a small current flows through the input, with the source of the higher current being from the capacitors in the power supply. Transistors are made from silicon, which is a semiconductor, meaning that it is not as good a conductor as something like copper or silver, and it is not as good an insulator as plastic. Other elements are added to the silicon, which is called doping, to alter its properties. If the elements are antimony, arsenic, or phosphorus, this silicon can be easily negatively charged and is called an N-type. If the elements are aluminum, boron, or gallium, the silicon can easily be positively charged, called a P-type. The charging is accomplished by the direction of the electrical signal flow, or bias voltage, that is placed upon it. While N-type silicon is easily negatively charged, it can be forced to be positively charged, and the reverse is true for P-type silicon. Here is a diagram of an NPN and PNP transistor, showing an input small current and the resulting large current output. The flow is reversed between an NPN and PNP. This represents the flow in a push-pull circuit, where the positive half of the waveform would be passed through the NPN transistor, and the negative portion of the waveform would be passed through the PNP transistor. A voltage difference of at least 0.7 volts between the base and the collector for NPN and between the base and emitter for PNP is necessary for current to flow. These two diagrams are of bipolar transistors, which are called bipolar junction transistors. FETs will be discussed next. While bipolar transistors are current operated with low input impedance, a second type of transistor called a field effect transistor, or FET, is voltage operated with high input impedance. Both bipolar transistors and FETs can act as voltage amplifiers and current amplifiers. The difference is the input control mechanism. Keep in mind that they do not magically change low voltages or low current into high voltages and high current. They input a low voltage or low current and then allow a higher voltage or higher current to be passed through the output. The high voltage is taken from a bias voltage that is placed at the output, and the high current is taken from the power supply. The FET has three connections like a bipolar transistor, and their functions are similar, but they are designated differently. The base in a bipolar transistor is equivalent to the gate in an FET. The bipolar collector is equivalent to the FET drain, and the bipolar emitter is equivalent to the FET source. FETs have N and P as well. There are several types of FETs. 1. Junction FET or JFET. 2. Metal oxide silicon FET or MOSFET. 3. Dual gate MOSFET. 4. Metal silicon FET or MESFET. 5. High electron mobility transistor and pseudomorphic high electron mobility transistor or HEMT, PHEMT. 6. FinFET. 7. Vertical MOS or VMOS. 8. Lateral MOS. Not all of these are used in hi-fi audio. Some are for radio frequency purposes. Shown in this photo is a summary diagram of a triode tube, bipolar transistor, JFET, and MOSFET with the corresponding connections. Voltage between connections 1 and 3 result in current flowing between connections 1 and 2. The input voltage varies with the musical signal, and the output current varies accordingly. Single transistors, as opposed to multiple tiny transistors on a chip, are manufactured in several ways. The first way is by diffusion. An N-type wafer is heated in a furnace and P-type gas is introduced, which diffuses onto the surface of the N-type wafer. The wafer is then covered with a mask that has small holes in it, and N-type gas is diffused onto the P-type surface. In the epitaxial method, N-type or P-type layers are grown on a substrate that is the same type, with a high level of doping. Each layer is grown onto the previous one to create an NPN or PNP transistor. The fused or alloy technique is executed by placing a very small bit of either aluminum or indium on each side of an N-type wafer. The wafer is then heated to the point where the aluminum or indium melts. When the wafer cools, the transistor is created. For the point contact technique, a wire containing P-type material is held against an N-type wafer, and a large current is passed through them, bonding the P-type and N-type semiconductors together. With rate-grown transistors, a germanium or silicon crystal is lifted from their molten form in a crucible with P-type or N-type doping elements added as the crystal is lifted. Bipolar transistors are thought to have a very dynamic audio sound, while FETs sound warm. However, this depends on how the transistors are implemented. So I have seen opinions that there is no difference in the sound of these two types of transistors. One particular type of JFET, called a VFET, technically called a static induction transistor or SIT, deserves special note. It was created back in the 1970s by Tokina, a company in Japan. It has a lower drain impedance so that it sounds similar to a triode tube, that is to say warm, which probably means more even-ordered harmonic distortion, as opposed to the other FET types, which are more like pentode tubes, which sound more neutral. Token was wiped out by the Fukushima earthquake in 2011. The amplifiers made back in the 1970s using the VFET transistors are prized by collectors. Current amplifiers using VFETs include the First Watt SIT-3. It is a single-ended, single-stage, pure Class A amplifier and is characterized by a warm, lush sound, the same sound as a single-ended triode tube amplifier. It has one VFET for each channel and outputs 18 watts per channel into 8 ohms. It is priced at $4,000. There is a rumor that VFET SITs will be manufactured in 2023 or 2024 in response to the large degree of interest. The newest transistor designs emphasize high-frequency switching efficiency, which means audio amplifiers that use switching technology. These amplifiers have existed for some time, but recent developments have allowed for very high switching frequencies, such as 600 kHz. Instead of supplying a continuous voltage that follows the audio signal, they switch on and off, which increases amplifier efficiency. They have more noise than non-switching amplifiers and more distortion in some respects, but they are probably the future of high-end audio, and they are routinely used now in home theater receivers that have all of the new channels in Dolby Atmos movies. Switching technology allows for the receiver to have 9 or more power amplifiers for all those channels without the receiver weighing 150 pounds or costing a fortune. The sound characteristics are still open for discussion. A higher noise floor buries some of the harmonic distortion peaks, and that does affect the tonality of the sound. Because newer transistor designs focus on high-frequency switching, some amplifier manufacturers have purchased large inventories of older transistor designs that they prefer. You can see a more detailed description of how switching technology works in Video 3 of our series Stereo Audio and Home Theater 101 Plus. I am indebted to Nelson Pass from Pass Laboratories for assistance in the preparation of this video. Thanks for watching.